In the last section, we refactored our project a little bit to make use of a promise. We're now going to continue by talking about exactly what a promise is and how we used it inside this project. So first off, a plain English definition of a promise. A promise is a tool that we have for managing asynchronous code flow throughout our application. And so once I say that, gee, that doesn't sound very plain English, does it? Essentially, a promise is a tool for handling any code that is going to execute at some point in the future. And that's exactly what's happening with the set timeout. We are saying execute this logic right here 2 seconds in the future. So at any point in time where you have some amount of code that's going to execute at some amount of time in the future, you want to be thinking promises. And this is highly relevant for working with databases for reasons that you'll see in just a little bit. Anyways, back to promises. When we create a promise by using this new promise structure right here, we pass in a function. The function right here is called with the resolve and reject keywords. And so resolve and reject, excuse me, I said keywords, I meant to say functions. The resolve and reject functions. The resolve and reject functions allow us to manipulate the state that a promise is in. And so that last part is probably the most important part about promises. Let's talk about exactly what I mean by state that a promise is in. By default, a promise has 3 different possible states. We will refer to it either as being unresolved, resolved, or rejected. When a promise is unresolved, it means that we're just kind of waiting around, twiddling our thumbs, waiting for something to finish. And so this is exactly the case when we are waiting for our user to click on the button. During those 2 seconds where the user has the opportunity to click on the button a whole bunch, our promise is in the unresolved state. It means we're waiting for the user to finish up all their possible clicks. After those 2 seconds, the promise enters either the resolved or rejected state. When a promise is resolved, it means, hey, the operation finished. Like whatever long-running operation that was, it ran, everything went A-OK. Everybody was all happy about it. Alternatively, a promise can be rejected. Rejected means something didn't go quite so well. In the context of our game, we consider the promise to be resolved if the user successfully clicked on the button at least 6 times. And we consider it to be rejected if they didn't click on it 6 times. The important thing to note here is that it's really up to us, the developer, to decide what constitutes a resolved or rejected promise. So I decided to say that if a user lost the game, something went wrong, and I wanted to reject that promise. And I decided to say that if the user won and they clicked on enough, then I resolved the promise, meaning to say everything went A-OK, the user won the game. We can change the state of the promise by calling either the resolve or reject functions that are passed to the promise itself. If we call resolve, the promise enters the, as you might guess, resolve state, and if we call reject, it enters the rejected state, which is rejected right here. Once we either resolve or reject the promise, any callbacks that we add to the promise are then called. So note that when I called start game right here, I chained on a .then and then a .catch. The first thing to take note of here is that when I called start game, it returned the promise that was created. So when I add on the .then and the .catch, those are being added onto this new promise that I created right here. When I resolve the promise, any function that I pass to .then will be called. And when I reject the promise, any function I pass to .catch will be called. Because my promise can only ever be either resolved or rejected, we know that only the functions that we pass to .then or the function I pass to .catch will be called. Never both. It's always one or the other. When a promise is resolved or rejected, it enters that state and that is it. It will never ever change again. So once you resolve or reject it, that's all you get. Now the last thing I want to tell you about promises is that I've shown you kind of the entire big picture of them. Both how to create a promise with this new promise keyword up here and this resolve and reject thing, and how to make use of it by adding on the .then and the .catch. The important thing to keep in mind here is that the absolute vast majority of libraries that you will use that make use of promises, and I'm talking about like jQuery or Axios or Mongoose, which we'll be using inside this course, do not require you to implement this side of the promise, the actual like promise creation side. As a developer, it is much more common for you to make use of the consuming side of the promise, where you will chain on the case to handle the success of the promise or the error of the promise. So if this code up here looks a little bit crazy, hey, don't sweat it. You're not going to be seeing this side of things too often, if ever, really. It's much more common that you'll be working on this side of the equation, where you make some call to a function, and then it's up to you to chain on some logic to add on for handling the success or the failure of that operation. Okay, so again, this is just a little bit of an overview of promises. It's just intended to be a little bit of a refresher. As we use promises throughout this course, you're going to see an incredible number of different implementations of them. Like every single section we go through is going to make a promise. So even if this looks a little bit mysterious right now, you know exactly what's going on, hey, don't sweat it. You're going to get so much practice with promises that you're going to be absolutely sick of them by the time this course is over. Okay, so now that we've gone over promises, let's continue the next section and start getting a handle on MongoDB.